We are recording. Let's share our screen. And it's going to look weird for a second. There we go. But now let's open this guy up. Let's get rid of that little piece. There we go. Okay, so chapter 5 deals with systems of equations, and we're going to figure out how to solve these things and basically what do they mean. So let me go through the first problem. Let's see if we can't make sense out of this. See if I can get my pen to work. Sometimes it's all right. So since the first problem here says we're going to solve by graphing, what I want to do is I want to think about this slope-intercept form, the y equals mx plus b. Okay, and I'm going to look at my first equation. I'm going to write my first equation, I don't know, in green. Y equals a negative 3x. Okay, so when I look at that first equation, this is just telling me that my m is negative 3. I'm going to think about it as negative 3 over 1 because we often call the slope the rise over the run. And then since I don't have a number over here where my b is, my y-intercept is the point 0, 0. So I'm going to go ahead and put my 0, 0 right there. And then since my slope is negative 3 over 1, I'm going to go down 1, 2, 3, and to the right 1. And I'm going to try to draw my line as straight as I can. There we go. Okay. So there's my first line. And then I'm going to do the same exact thing with my second line. So my second line right now is 2x minus y equals a negative 5. And what I'm going to do is I'm going to switch my y and my 5 because I want to get my equation so that it looks like this. Okay, so basically I have y by itself. So if I move this y over here and I bring this 5 this way, let's see what's going to happen. The 2x is going to stay the same. Since I'm bringing the 5 over, and right now the 5 is negative, it's going to become positive. And since the y right now is negative, when I bring it over, it's going to become positive. And so again, I can rewrite this just so that it looks like this. Oops. Y equals, let's see, 2x plus 5. So when I look at this part here and I think of my y equals mx plus b, then I can say, hey, look, my m is 2 over 1, and my y-intercept is at 0 and 5. So the first thing I'm going to do is I'm going to go up to the point 0, 5, which is right here, okay? And then I'm going to move up 2 and then to the right 1. So I'm going to go up 1, 2, and then to the right 1 right there. And I'm going to start connecting my dots. So let me see if I can do this. 1, 2, here we go. Okay, so now I drew the second line, okay? What it is we're really trying to find is we're trying to find the point where those two lines cross, okay? And again, I'm doing this freehand, so my lines are coming up a little bit messy. But what we should be coming up with is we should be coming up with the point -1 and +3. And so what that tells me what I'm looking for. I'm looking for the point where the two lines meet. Hello. I'm looking for the point where the two lines meet. So when I draw both lines, I can actually see what's happening here. So I draw both lines and I say, hey, look, these lines meet at the point -1, 3. And the way I can verify that, right, the way I can make sure that I'm telling you all the truth and I'm not just kind of poking you on the eyes here, I can say, look, here's my point, right? And let me look at my two equations. So I'm going to do this part on the side. You don't necessarily have to do this part, but if we were going to check it, right, and we have the point -1, 3. My first equation was y equals -3x, right? So remember what this means. This is the value for x. This is the value for y. So if I were to replace my y with a +3, and I were to replace my x with a -1, we would say 3 equals -3 times -1 is +3. Yeah, that actually does check out. So I know that that point works in the first equation. And then if I wanted to check my second equation, if you remember our second equation, so I'm still using the same point, negative 1, 3. Our second equation was originally 2x minus y equals a negative 5. So if everywhere I have an x, I replace it with a negative 1, and everywhere I have a y, I put a positive 3. We can do the same thing. We can check. So 2 times negative 1 minus y, which is positive 3, is supposed to be equal to negative 5. So 2 times negative 1 is a minus 2, and minus 2 minus 3 is in fact equal to negative 5. And so that's really what it is we're doing. So again, the check, you don't have to do the check. I just want to show you all that what I'm really doing here, and I know I zoomed out a whole lot. I'll zoom back in and I'll zoom out again if y'all need it. But what I'm trying to show y'all here is that what I'm doing is I'm drawing the two lines, and I'm just looking for the point where those two lines meet. And because when we talked about lines back in chapter 2, we said one of the ways that we can draw a line is by thinking about this y equals mx plus b form. Then once I draw my lines, I find the point where they meet, and that's what we're looking for. That's our solution set. Now, there's a lot of great things about the graphing method. The graphing method, what I like about it, it's visual. There's the answer. I can see exactly, once I draw my two lines, I can see where those two lines meet. And when you do this on MyLab, because we have a little line feature and it draws a line nice and perfect for us, you're never really going to have to guess. You're going to be able to find the point nice and neat. Here I did mine freehand, so my lines are a little wavy. The drawback is you have to draw a line every single time, and it can get a little time consuming. So we have other ways that we can solve systems of equations using algebra where we don't have to do the whole draw the line every single time. Okay, so let's take a look at this next one. It says solve by the method of substitution. So the method of substitution says we're going to look at these two equations and we're going to see, is one of those equations already solved for the letter x, or is it already solved for the letter y, or is it easy for me to solve for x or y? So when I look at this equation, I know that the second equation already has the letter x all by itself. So what we're going to do is we're going to take this and we're going to substitute it into the other equation. So the top equation says x plus y equals 3. But instead of me writing an x, x is the same thing as 2y plus y equals 3. So all I did is I took this part here and I plugged it in right there. Instead of me writing an x, I know that x was equal to 2y, I plugged that part in. So now remember, this is really a 1y. So 2y plus 1y is a 3y is equal to 3. So when we divide both sides by 3, we get y equals 1. Now again, what is it we're trying to find? We're trying to find the point where the two lines meet. Every point has two coordinates, x and y. So we know the y coordinate. The one we're still trying to find, we're still trying to find the x coordinate. So what we're going to do now is we're going to take this value, y equals 1, and we can plug it into either one of those equations. It really doesn't make any difference which one we do. We're going to get the same thing. So let me show you. Suppose I use the first equation. X plus y, which is now 1, is equal to 3. When I subtract 1 on both sides, I get x equals 2. So now we found the point where those two lines meet. When x is 2, y is 1. So this is what I'm looking for. We're looking for just the point where they meet. Now I told you, it doesn't make any difference. Once you find your first value, does it make a difference if you use the top equation or the bottom one? No, it doesn't. Right now we use the top equation and we got x equals 2. But if we use the bottom equation, you're going to see, look, x equals 2 times y. Y was 1 already. And 2 times 1 is still 2. Which equation do you use? You get to decide. You're going to get the same thing every time. Okay? So again, what I'm doing here, y'all, is I'm looking to solve the system of equations, and I'm trying to find the point where the two lines meet. So let me go to the next problem. Oops. We're going to do the same thing here. So again, the method of substitution says, can I solve one of those equations either for the letter x, or the letter y? And which equation would it be easy for me to solve for? So remember what it means to solve for x or y. It means to get the letter by itself. If I look at this bottom equation and I decide I want to get the letter y by itself, all I would really have to do is move that 4 over, and we would end up with y equals a negative 2x minus 4. All I did is move the 4 from one side to the other. And so now we have this value of y. So now that we have that, we're going to plug that into the top equation. So the top equation says 4x plus 2 times y. But remember, y is now equal to a negative 2x minus 4 is equal to 5. Okay? So if I start to solve this equation here, I'm going to say, look, 4x, 2 times negative 2x is a minus 4x, 2 times negative 4 is a negative 8, is equal to 5. And then I want you to notice something. My x's are actually going to cancel out, and we end up with something like negative 8 equals 5. But we know that that's not true. Negative 8 is not equal to 5. So when all my letters cancel out, what we say here is there is no solution. Okay? Again, I want to go back and think about what is it I'm trying to find. I'm trying to find the point where the two lines meet. And we came up with no solution. So again, you don't have to do this part, but I just want to give you all like a visual of what's happening here. So on a visual basis, what's really happening is okay, so what's really happening here is one line looks like this. And let me see if I can think about the other one for a second. And the other line looks like this. And so if you notice, those are parallel lines. And parallel lines never meet up, okay? And so that's why we say there's no solution. So again, what I'm really trying to do here in all these problems, again, if I go back and I think about the very first problem that we did tonight, this one here, I'm looking for the point where the two lines meet, okay? And so we did this problem here. We did it graphically. We drew the two lines. We used that y equals mx plus b form that we talked about back in chapter 2. And then for these next two problems, we did this algebraically. So we did it without having to draw the lines. And we know how to solve equations. We know how to manipulate, distribute and all that kind of good stuff. And on the second one, we didn't come up with an answer because we got something like all the x's canceled out and we got negative 8 equals 5, which we know isn't true. So that just tells me that there's no solution, okay? So now let me move down a little bit further. Okay, so now we have another way we can solve these things, and it's called the elimination method. And so the elimination method says we're going to try to eliminate one of the variables, either the x or the y. And the way we're going to try to do this is we want to get the same number in front of the x or the same number in front of the y, but we want them to have opposite signs. So I know it's not really the same number, but like if the number in front of one x and my x in the first equation, say that was a 7, then I would want the other one to be a negative 7x. So if I had a 7x and a negative 7x, or if I had a negative 5y and a positive 5y, something like that. That's what I'm trying to get to, okay? So when I look at this problem here, the first thing I notice is the number in front of the y in the first equation is a 1, and the number in front of the y in the second equation is a negative 1. So again, I have opposite numbers. One of them is positive, one of them is negative. The absolute value of those numbers are the same. So like, I know one is positive, one negative, one, but same number, opposite signs. When we add straight down, that's what we're going to do. We're going to add straight down. So 4x and 2x is going to leave me with a 6x. Now, when we add straight down, those y's are actually going to cancel out. And when we add straight down over here, 13 and 5 is going to leave me with an 18. So now I just have the equation 6x equals 18. So we can divide everything by 6. And I'm coming up with x is equal to 3. Okay. All right. So now that we have x equals 3, remember, we still need to find the value of y, because every one of these is going to be written in the form x and y. So what do? We can go back to either one of those equations. We can use the top one, we can use the bottom one. Which one do we use? We get to pick. I'm going to pick the top equation right here. So I'm going to put 4 times x, which is now 3, plus y equals 13. So 4 times 3 is 12, plus y equals 13. So when I subtract 12 on both sides, I'm coming up with y is equal to 1. So what does that mean? It means the solution to my system is the point 3 and 1. Okay. All right. So look, I'm going to do the same thing here. Remember what the objective is. I want to get the same number in front of the x, or I want to get the same number in front of the y, but I want them to have opposite signs. Okay. So I look at the top equation. It's 3x plus, I can think about that as a 1y equals negative 11, and 6x minus 2y equals negative 2. So I know that the number in front of that y right now is a negative 2. I would really like the number in front of this y to be a positive 2. So the way we can do that is we can multiply everything in the top equation by the number 2. So look, I'm going to multiply everything in the top by number 2. So 2 times 3x is 6x, plus 2y equals a minus 22. And then we have a 6x minus 2y equals negative 2. And we're going to add these two equations together. We're going to add them straight down. And that's going to leave me with a 12x. These y's are going to cancel. Minus 22 and minus 2 is a minus 24. Okay. And then what I'm going to do now is I'm just going to divide everything by 12. And I'm coming up with x is equal to negative 2, right? Okay, so just like we did before, now we know the value of x. Let's go back and let's find the value of y. Okay, how can we do that? We can plug in that value x into any equation we want. We can plug it into the equation before we multiply by 2. We can plug it into the equation after we multiplied it by, oh, come on, pen. After we multiply it by 2, or we can plug it into that one. Okay, it doesn't really make any difference. I'm going to go with the one before we multiplied everything by 2. So I'm going to put 3 times negative 2 plus y equals minus 11. So this is a negative 6 plus y equals minus 11. And then so when I add 6 to both sides, I end up with y equals negative 5. And so my solution here is negative 2 and negative 5. And it's written as a point because this is the point where those two lines end up meeting, right? So we have a couple of ways of solving these problems. One way is we can draw the two lines and find where they meet. The other two ways are using algebra. You can either solve it using the method of substitution, which says solve one of those equations for a certain letter, whether it's x or y, it doesn't really matter. Plug that into the other equation and solve it. And then once you get your first value, find your second. And then the method of elimination says we want to eliminate either the x's or the y's. Which ones do you eliminate? You get to choose. What you want is the same number in front of the x or the same number in front of the y, but you want them to have opposite signs. So again, if the number in front of the first, on the x in the first equation, if I have a negative 5x, I want to get a positive 5x on the other one. If I have a positive 7y, I want to get a negative 7y on the other equation. So that when I add them together, they will eliminate. They'll cancel each other out. That's what we're trying to do. Okay. And here we go. Here's another one. So we'll go ahead and stick with the same process. We're going to go through the process of elimination. So we get to decide, do we want to get rid of the x's or do we want to get rid of the y's? So in the last two problems, we ended up getting rid of the y's. Let's see if we can get rid of the x's, okay? Again, it doesn't really matter, but let's just make sure that we can do it in case we thought we only had to get rid of the y's. You can get rid of the x's. So I noticed that the number in front of this x is a 4. So if that one's a 4, I would really like this one here to be a negative 4. So how can I make that positive 2 into a negative 4? We can multiply the bottom equation by a negative 2. So first thing I'm going to do, I'm going to rewrite the top equation. I'm going to leave it alone. 4x plus 3y equals a minus 1. And then I'm going to multiply the bottom equation by a negative 2. That's going to give me a negative 4x, a minus 10y equals a negative 6. Okay? And so what we're going to do now, we're going to add straight down. So look, these 4x's are going to cancel. 3y minus 10y is a minus 7y. Minus 1 minus 6 is a negative 7. So when we divide both sides by the number negative 7, we come up with y is equal to positive 1. Okay. All right, so now we know y is equal to positive 1. So look, I'm going to take the bottom equation. The bottom equation was 2x plus 5y was equal to 3. Again, I can use the top equation, y'all. I can use the bottom equation. It really doesn't make any difference. I'm going to end up with the same value anyway. But I'm going to plug in y equals 1 right into here. So this is going to give me 2x plus 5 times 1 equals 3. So 2x plus 5 equals 3. So now when I go minus 5 and minus 5, those are going to cancel. This is going to leave me with 2x is equal to a 3 minus 5 is a negative 2. So when I divide both sides by 2, I'm coming up with x equals negative 1. And if x is equal to negative 1, then, and I know that y is already equal to positive 1, the solution is negative 1, positive 1. Remember, the solution, y'all, is always written first x and then y. Okay. Now, in the past, I've had people ask me, which way is better? Is it better to do substitution? Is it better to do elimination? I think it depends on the problem. So like when I look at this next one here, right? 5x plus 7y equals 6, and then 10x minus 3y equals 46. Like to me, this problem is set up for me to do elimination. And the reason I would say that is I know that this number here is a 10. So I really want the number in front of the x in the top equation, I really want this number here to be a negative 10. And the way I can do that is by multiplying it by negative 2. So look, if we do that, remember, we're going to do negative 2 all the way across. That's going to be a negative 10x, a minus 14y equals a negative 12. And then the bottom equation is going to stay 10x minus 3y equals 46. And then what I'm going to do is we're going to add straight down. Okay? So when we add straight down, the 10x's are going to cancel. We've eliminated them, right? A minus 14y and a minus 3y is a minus 17y. And then negative 12 and 46 is a 34. So if I owed you $12 and I had 46 and he said pay me, I would walk away with $34. Okay, we're going to divide everything by a negative 17. And this is giving me y equals a minus 2. Okay. All right, so now that I have y equals minus 2, I still got to go back and find x. Which equation do I use? Again, doesn't really matter. Let's take, say, this one. And the only reason I'm taking this one, the numbers are a little bit smaller. Okay. So look, I'm going to go 5x plus 7 times negative 2 is equal to 6. So 5x. 7 times negative 2 is a minus 14 equals 6. So let me add 14 to both sides. So this is giving me 5x is equal to 20. So when I divide both sides by 5, I'm coming up with x is equal to 4. So again, as a point, these two lines meet at the point 4 and negative 2, right? So again, that's all we're really doing here in 5.1. Let's see. Let's go ahead and take a look at this next problem. Again, we're going to use the same sort of steps we've been using before. Okay. So now I want you to notice something. We have three equations. We have an x plus y plus z equals 2. We have a 2x plus y minus z equals 5. And we have an x minus y plus z equals negative 2. Okay, so I'll tell you what. Let's take the first equation and the second equation, and let's add those two equations together. Okay. So if I take these two equations here and I add them together, I'm just going to add straight down. That's going to leave me with a 3x and a plus 2y, is equal to 7. Okay? And then, let me see. Let me take let me take the second two equations and let me add those problems together. And let me see what we end up with. Let's see, if we take these two and add them together, let's see, 2x and 1x is a 3x. Let's see, a plus y and a minus y cancel. A plus z and a minus z also cancel. 5 minus 2 is equal to 3. Okay. All right, so now I have 3x is equal to 3. So look, if we divide both sides by 3, we come up with what? X is equal to 1? Okay. So now we know x. We still got to find y. We still got to find z. But I'll tell you what. Remember when we added the first two equations together? When we added these two equations, we came up with this one here. Let's take this value of x and let's plug it in there. Okay. So we're going to go 3 times 1 plus 2y is equal to 7. So this is 3 plus 2y equals 7. So when I subtract 3 on both sides, I end up with 2y equals, let's see, 7 minus 3 is 4. And if we divide both sides by 2, we get y equals 2. Okay. So we know X, we know Y, we still don't know Z. So now we have some options. We can come back to our original system here, right? Come back to these equations, and everywhere we have an X, we can put a 1. Everywhere we have a Y, we can put a 2, and we can find Z. Which equation do we use? We get to pick. Oh, I don't know. Let's pick the top equation. So where the X was a 1 plus, where the Y was a 2 plus Z equals 2. So 1 plus 2 is 3 plus Z equals 2. So when we subtract 3 on both sides, I'm coming up with Z is equal to 2 minus 3 should be a negative 1. Okay. Now, let me show you how we're going to enter these answers in. So remember when we had 2 points, we would always go X and Y? So now that we have 3 values, y'all, this is how we're going to write it. X, Y, and Z. So we're going to have 1, 2, and negative 1. Let's see. Caleb is watching. Good. Caleb, I'm glad you're here. I'm hoping this is helping. All right. Okay. So now let's go through the last section. So y'all, this is 5.3. This is the last section of the class. So if you're sad, don't be sad. I'll teach you another section in another class another day. But this is it for us, okay? This is the last section of our class. So let's take a look at what we got here. It says 5.3 talks about these things called determinant solutions of linear systems. Okay, so first thing we have is we have these things called a matrix. A matrix is just like an arrangement of numbers, okay? That's all it is. It's just an arrangement of numbers. Not doing anything special with a matrix. I'm just kind of organizing my numbers here. And we're going to have something called the determinant. Okay, so when our matrix cell looks like kind of like big brackets like this. And the way we know that we're finding the determinant, it looks just like the absolute value. Okay, so it's just like the little lines here. So we're going to find the determinant of this matrix here, -3, 4, and 6 and 8. Okay. So I'm going to show you all the process and how I find the determinant for what we call a 2 by 2 matrix. The reason why we call this 2 by 2 is, give me 1 second. So Caleb, I just saw your message right now. It isn't. We still have the final. So if you notice, test 2, Caleb, only goes up to chapter 4. The final is including what I'm doing right here. It's including these 2 sections from chapter 5. Okay. But I'll send you a message in a little bit too once I'm done with this part here. So let's take a look. This is how we find the determinant. What we do is we multiply these numbers together. So we're going to take -3 times 8, and then we're going to subtract multiplying these numbers together. 6 times 4, 24. Okay. So look, right here, -3 times 8, -24, minus another 24, -48. This is how I find the determinant of a 2 by 2 system. Okay. We're going to do it again. We're going to find the determinant of this matrix right here. Again, let me show you how I'm going to do it. We're going to multiply these numbers on the diagonal. So I'm going to take -5 times -1 minus these on the diagonal. 4 times 9. So -5 times -1 is a +5 minus 4 times 9 is 36. This is leaving me with a negative 31. Give me 1 second down. All right. Okay, so I got another 2 by 2 system, and I'm going to find, again, the determinant of this matrix. So I'm going to multiply these right here. So we're going to go 3 times negative 2 minus, it's always minus, y'all, these diagonals. 5 times 4. So 3 times negative 2 is a negative 6 minus 5 times 4 is 20. This is a minus 26. All right, same thing here with this one. I'll go through the same process again. So we're going to go 9 times negative 1 minus, we're going to multiply these right here, negative 3 times 3. So 9 times negative 1 is a negative 9 minus negative 3 times 3 is also a negative 9. And so minus and minus become plus, and there's my 0. Okay. Okay, so finding the determinant of a 2 by 2 matrix, you're multiplying along the diagonal. You're going from the top down to the bottom right, and then minus from the bottom left to the top right. Okay, so now I'm going to show you how to do the same process, when we have what we call a 3 by 3 matrix. Okay, so the way we're going to do the determinant here, y'all, is the first thing I'm going to do, I'm actually going to rewrite my problem so it's a little bit bigger so I can have some room to work with here. Okay, what I'm going to do, y'all, I'm actually going to copy these 2 columns. I'm going to rewrite them again. Over here to the side, I'm going to put 4, 2, negative 6, and negative 7, 1, and 3. And I'm going to explain to you right now why am I doing it that way. Okay, so the way, just like the way we were doing before, we were going along the main diagonal. I'm going to go along the diagonals here. So look, this is going to be my first diagonal. So I'm going to write this out. I'm going to have 4 times 1 times 0. Okay, and then we're going to add, and I'm going to do the next diagonal. Negative 7 times 3 times negative 6. Okay, and then I'm going to do the next diagonal. Plus 8 times 2 times 3. Okay, so again, if you notice, I'm just going along the diagonals. Okay, now before we were doing some subtracting, so now we're going to do the subtracting part. I'm going to go from the diagonal from the bottom left to the top right. These are all going to be subtracted. So let me show you how I'm going to do this part. I'm going to put a minus, and I'm going to use brackets. And I'm going to put negative 6 times 1 times 8 plus, I'm subtracting the whole value, but I'm adding each of these individually. 3 times 3 times 4 plus these here. 0 times 2 times negative 7. Okay. All right. So now let me go ahead and keep going. So first part right here, remember I'm multiplying. 4 times 1 times 0, that's just 0. Plus 7, negative 7 times 3 times negative 6. Oh, I don't know. I'm going to grab my calculator so I can figure that out. Let me turn it on. Here we go. Clear it out. So I'm going to go negative 7 times 3 times negative 6 is 126. Plus 8 times 2 times 3. 8 times 2 times 3 is 48. Okay. Minus, now I'm going to start doing these. Negative 6 times 1 times 48, that's a negative 48. 3 times 3 times 4, that is a positive 36. 0 times 2 times negative 7, that's still 0. Okay. So let me do the same thing here again. So I'm going to go 126 plus 48 is 174, so that's 174. And then let's see, minus, negative 48 and 36 is a negative 12. And then, so this is going to give me 174. Minus and minus become plus. So this should be something like 186. Oh yeah, I'm multiplying. Yeah, yeah. Every number inside those parentheses are being multiplied, and but then I add up each of those individual values, right? So so like these numbers are being multiplied here. So like 4 times 1 times 0 gave me 0, right? Negative 7 times 3 times negative 6, 126. 8 times 2 times 3, 48. Minus, right? Now I'm going to come here, multiply. That's negative 48. That's 36. That's 0. So then what I do now is I combine these two together to give me my 174. When I combined these here, it actually gave me a negative 12, right? But remember, minus and minus become plus, and that's where we got our 186. Okay, so look, let's try another one. We'll go through the process same exact way. Again, I know these problems get tedious. I'm going to show you what the whole point of us doing this is, okay? So first thing I'm going to do, when I see my matrix, I'm going to copy the first two rows again. 7, 1, negative 2, negative 1, negative 7, positive 1. Always just the first two, okay? Just the first two. Okay, and I'm going to use green and I'm going to use red just again so you can kind of get the idea of what it is I'm doing here. So look, I'm going to make a diagonal along here. So I'm going to put 7 times negative 7 times 1, okay, plus, then I'm going to make another diagonal right here. Negative 1 times 2 times negative 2, and then I'm going to make one last diagonal right here. 1 times 1 times 1, okay? And then I'm going to get rid of those little, okay. And now I'm going to do the next part in red. So if I'm going to go minus, okay, and I'm going to multiply those. Negative 2 times negative 7 times 1, plus, and then I'm going to do these right here. 1 times 2 times 7 right here. And then I'm going to do one more right here. 1 times 1 times negative 1. Okay. Okay, so now I'm going to go real slow because I don't want to make any mistakes here. And this, if we're not going to make a mistake, y'all, this is where it's going to be. Just because I have so many numbers that I'm actually multiplying out. Okay. So let's take a look. 7 times negative 7 times 1, that is a negative 49. Plus, let's see, negative 1 times 2 times negative 2, that should give me a positive 4. Okay. Come on, 10. Positive 4. And then 1 times 1 times 1 is still 1. Okay. Minus, now I'm going to put all this part in my brackets. Negative 2 times negative 7 times 1 is a positive 14. Plus 1 times 2 times 7 is another 14. And 1 times negative 1 is a minus 1. Okay. So again, all I'm doing, I'm multiplying. Guys, if it helps you using your calculator, use the calculator, okay? Don't let me multiplying without my calculator affect you, okay? Don't worry about it. Okay, now I'm going to go really slow here. So look, I have a negative 49. 1 plus 4 is a 5. Minus, let's see, 14 and 14 is 28. Minus 1. I'm almost done here. Let's see. Negative 49 and 5 is a minus 44. Minus, let's see, 28 minus 1 is 27. So now I'm just going to grab my calculator. Let me turn it on. There we go. Clear it out. So I have a negative 44 minus 27, and that's giving me a negative 71. Okay. And so again, I'm able to find the determinant of my, excuse me, of my 3 by 3 matrix. Okay. Again, it takes a little time to do. There's no doubt about it, y'all. These problems can be a little time consuming, but I'm hoping that as I'm going through these problems, you understand the process. You can see how I'm doing my diagonals, okay? So I always go from the bottom left to the top right this way, and these, as I do these all get added together. And then when I come down, I'm sorry, from your perspective, yeah, this way, coming down. These here, I take the 3 and I multiply each of those numbers and I add them together. And then when I go this way, I do the same thing, but I add those together, and then whatever answer I get, I'm going to subtract it from the first one. Okay? So that's why when I wrote it here, again, and I'll do the part in green just so you can see again. So this was my first one, this was my second one, and this was my third one. And each of those numbers, we added them, and then we subtracted all of the red ones added up together. Okay? Okay, so now I'm going to show you a process on how we're going to solve a system of equations using something called Cramer's rule. So the whole point of us doing that determinant business a little while ago was we use that in doing Cramer's rule, okay? So Cramer's rule says if we have two equations, they call it A1x and B1y equals C1. The reason why they're using the ones, it's the first equation, okay? And my numbers A, B, and C are just whatever numbers we have, 3, 4, 5, negative 7 to 11, whatever happens to be. And then A2, B2, or A2x plus B2y equals C2. So there's a way that we can solve this thing. And the way we solve it is by using Cramer's rule, and we have these solutions here. And they tell us how to find dx and how to find d and how to find dy and how to find d, okay? So let me go through the process. Let me show you what I'm going to do. The first thing is we're going to write the way we're going to find the determinant for the matrix D. I want you to notice something. We're only using the A1s and the B1s and the A2s and the B2s. What does that mean? I'm going to write a matrix using the numbers in front of the X's and the Y's only. So when I look at this equation here, if it helps, I'm going to put 1s right here and a 1 right there. So I know the numbers in front of my X's and Y's in the top equation are both 1. And I know that the number in front of my X and Y's in the bottom equation, the first one is a 2, this one is a negative 1. Okay? This is how I'm going to compute the determinant of the matrix D. So remember how we do this? We said, look, we're going to go along the main diagonal. So we're going to take 1 times -1 minus, and then we're going to go this diagonal. 2 times 1. So let's do this part now. So we have 1 times -1 is a -1 minus 2 times 1 is 2, and that's giving me -3. So we found the value of D. The value of D is equal to -3. Okay, now we're going to write a determinant with this determinant we call him dx. So let me show you how we're going to do dx. Okay. Dx is going to look like this. I'm going to come back to my original equation. Okay, here's my original problem right here. My y numbers, which are the numbers in the second, kind of that second column right there, those numbers are going to stay the same. That's a 1, that's a -1, right? And I'm looking at the numbers in front of my y's right here, right? So I'm looking at the numbers in front of my y's. Now, the numbers in front of my x are 1 and 2. Instead of me using those numbers, I'm going to use the numbers that I have at the end. Those are going to be the numbers that I'm going to put right here. Okay? So what we really did is we took away the x values that we had, or the coefficients of the x, and we replaced them with the numbers that we had on the right side of the equal sign. Okay? Now, I'm going to find my determinant. Remember how we did this? We go diagonal. So I'm going to say this is going to be 4 times -1 minus 2 times 1. So this is a -4 minus 2. This is a -6. Okay. So I found my value for dx, and that happened to be -6. Okay. Now we got to do one last one, and it's called dy. Okay, so let me show you how I'm going to do dy. I'm going to come back to my original problem right here. Okay, so here's my original equation, and I'm going to write the coefficients of the x values. So remember, the coefficients are just the numbers in front of the x's. So the number in front of the x in the top equation is a 1. The number in front of the x in the bottom equation is a 2. But instead of me writing the coefficients of the y's, or the numbers in front of the y's, I'm going to replace them with those values. So I'm going to put a 4 here and a 2 here. Okay. And now we're going to go ahead and find our determinant. So remember, we're going to multiply these two right here. So 1 times 2 minus, and then I'm going to do these over here, 2 times 4. Okay. So 1 times 2 is 2. 2 times 4 is 8. So that's giving me a -6. Okay. So right here we have d, we have dx, and we just found dy also to be the number -6. Okay. All right. So now, how do we solve our system of equations? This is what we're going to do. X is equal to my dx number over d. So our dx number was a -6. Our d number was a -3. So -6 divided by -3 is a +2. Okay. Now, how do I find my y value? My y value is the answer that we got for dy divided by d. So what was the answer we got for dy? We got -6. What was the answer we got for d? -3. And let's see, -6 divided by -3 is also a +2. So what does that mean? That means that the solution to this system is the 0.22. Now I know what you're thinking. Man, that's a lot of work to do what we did earlier in 5.1, and we could have done it using those other methods and gotten the same answer. You're exactly right. We could. So one of the things that the state of Texas says is, I got to teach you guys Cramer's rule. This is how Cramer's rule works, right? It's a very obsolete way of doing stuff. We don't really use it a whole lot. The only time I ever use it is when I teach this class, and you're probably not going to ever use it, but I got to at least show you how it's done, okay? And in your homework, guys, for these problems, I gave you very limited. I didn't give you a ton of these problems, okay? I just gave you a couple, just so you could at least see how it works, okay? So look, we got 2 more problems to do, and then that's it for the night. So look, let's do another one, and we'll do the same process, and then if y'all have any questions about anything from the review, you guys can definitely ask me, okay? So let's see. First thing we're going to do, we're going to find the determinant of our matrix D, okay? So again, y'all, just so you can see, how do I find the matrix or the determinant for D? I'm using these values right here. So I'm going to go 5 and 7, 6 and 8, okay? So let's go ahead and do that. We're going to multiply on the diagonal, 5 times 8 minus, and then we're going to do this diagonal, 6 times 7. So this is 40 minus 42, that's a negative 2. So right here I'm going to say D equals negative 2. Okay. Now let me show you how I'm going to do dx. So this is how I think about it. Look at what I'm looking for. I'm trying to find dx, right? So I know that these values here are my x numbers. I'm not going to write those numbers. I'm going to write the numbers that I have over here where those x's used to be. So I'm going to put a negative 1 and 1, but I'm going to leave the numbers in front of the y's being the same. Okay? That's how I think about it. When it says dx, it means get rid of the x numbers that you had, and whatever numbers we had on the right side of the equation, we're going to put those numbers in their places. Okay? So now look, I'm going to do the same thing. I'm going to go along my diagonal. So we're going to say negative 1 times 8 minus 1 times 7. Okay? So negative 1 times 8, negative 8 minus 7, that's a negative 15. Okay? So dx is negative 15. Okay? We got one last one to do, y'all, and then we can find our answers, okay? So look, we're going to go dy. So look, I'm going to come back over here, right? I'm going to use yellow for my highlighter now. I know that those are the numbers right there in front of my y. So what that means is I'm not going to use those numbers. I'll use the 5 and the 6, but where the y's used to be, I'm going to replace them with those numbers that I had on the other side. So it's like get rid of the y's and use the other numbers that you had. Okay? All right. So look, we're going to do the same thing here. We're going to multiply across along the diagonal. 5 times 1 minus, I'm going to do this part here too, 6 times negative 1. So 5 times 1 is 5, minus 6 times negative 1 is a negative 6. So minus and minus become a plus. So here we go. dy is equal to 11. Okay. All right. So now that we have that, the way we find the x value, y'all, is we take dx and divide it by d. So remember what we got for dx. We came up with a negative 15. For d, we came up with a negative 2. And a negative divided by a negative is a positive. So my x value is just 15 over 2. Okay. And then the way we find y is we take dy divided by d. So dy is 11 divided by d, which is negative 2. That's just negative 11 halves. And then so the way I write my answer as a point is 15 over 2 and negative 11 over 2. Louder, did I do okay? Yeah, you sure? Okay, just checking. All right. So again, yeah, I know it's a lot of steps to do this thing, Um, one of the advantages of doing Cramer's rule, like in this case, y'all, if I were going to draw these two lines, right, and say, where do they meet? They don't meet at a pretty point like 3, -1, or they don't meet at a pretty point like 5, 2. They meet at 15 halves and -11 halves. And it's kind of hard to see that on a graph a lot of times. And so Cramer's rule and other processes do it the same way or do the same thing, but I'm able to find the solution without having to go back and look at the graph. Again, what is it I'm really doing here? I'm looking for the point where the two lines meet, okay? All right, so here is the last problem that we have, y'all. And so this last problem, this is very similar to what you guys have as your class assignment number 2. And so I'm going to walk you through, again, this process and show you how to do it. It's going to be a little time consuming, y'all. But what I'm hoping for is that we can do this process and we can kind of figure out, how do I do this, okay? So just like we did before, we were finding three determinants before. We found D, and then we found the dx, and then we found dy. We're actually going to have to do another one here. We're going to find the determinants for D, for dx, for dy, and in this case, we're also going to have a dz, okay? So let me show you how I'm going to do how I'm going to set up the determinant for the matrix D, or the values for the D. There we go. Okay. So what I'm going to do is I'm going to just use the numbers that I have inside here. So I'm going to go 2, -1, and 4, and 3, and 2, and -1, and 1, and 4, and 2. And just like we did before, y'all, I need to take those first two columns and copy them down again here. So I'm going to go 2, 3, and 1, and -1, 2, and 4, okay? And I'm going to try to go super slow, one step at a time. It's going to take a little bit of time. It'll probably take us about 10 minutes just to do this last problem. Maybe even take us a little bit longer, hopefully not more than 10. Okay, so remember what we're going to do here. To find our value for D, we're going to start taking these numbers. So we're going to go 2 times 2 times 2. And then we're going to multiply these here, plus -1 times -1 times 1, plus, and then we're going to do these right here, 4 times 3 times 4. Okay? And then we're going to go minus, and I'm going to put brackets. I'm going to multiply those together. 1 times 2 times 4, plus, and I'm going to do these right here. Okay? 4 times -1 times 2, okay, plus, and then one last set here. All right, 2 times 3 times -1. And close my brackets. Okay, so now let's see if we can figure this value of D out. Okay, 2 times 2 times 2 is 8. -1 times -1 is +1 times another 1 is still 1. 4 times 3 is 12, and 12 times 4 is 48. Minus, let's see, 1 times 2 times 4 is 8. 4 times -1 times 2 is a -8. And 2 times 3 times -1 is a -6. Okay. So let's see, let me grab my calculator here. Let me move it to the side so we can figure this out. 8 plus 1 plus 48 is 57. Okay. Minus, let's see, well, 8 and 8 are going to cancel. That's a -6. So that becomes plus. So what's 57 plus 6? I'm coming up with a 63. Okay. So there's my answer for the first part. We found this one. Okay. So look, y'all, we found one of those four. We still got to find three more. Okay. I'm going to show you how I'm going to do that right now. Okay. So look, we're going to do the dx part. So let me clean up this mess. Okay. Remember what the dx part says? It says, let's look at this thing right here. And I'm going to kind of zoom out just a little bit so I can start writing how I'm going to do my dx. Okay. Remember, I'm going to take those x values, and instead of using those x values, I'm going to use the numbers that I have on the right side, right? So I'm going to put a -2, a -3, and a 17. And then the rest of the numbers, I'm going to use the same numbers that I had. So we had a -1 and a 4, a 2 and a -1, and a 4 and a 2. Okay? And just like we did before, I'm going to take those first two columns, y'all, and I'm going to rewrite them over here. Okay. All right, so let's see if we can find our dx. So remember what I'm going to do now. I'm going to go along the diagonal. Okay. So dx is equal to -2 times 2 times 2 plus, right here, -1 times -1 times 17 plus 4 times -3 times 4. Okay. And then I'm going to go into red because that's what I've been doing because I got to subtract. So I'm going to go minus 17 times 2 times 4 plus, let's see, 4 times -1 times -2 plus 2 times -3 times -1. Okay. All right, so let me write it right here. dx is equal to, okay, -2 times 2 times 2 is a -8 plus, let's see, -1 times -1 times 17 is still 17 plus 4 times -3 times 4 is a -48 minus, let's see, I don't know what 17 times 2 times 4 is, so I'll use my calculator. 17 times 2 times 4 is 136. Let's see, 4 times -1 times -2 is a +8. And 2 times -3 times -1 is a +6. Okay. And so now I'm going to start combining these numbers here. So let me see, -8 plus 17 minus 48 is -39. -39 minus, I can add these guys all up together because they're all positive. 136 plus 8 plus 6, 150. And then let's see, -39 minus 150. So -39 minus 150 should be -189. Okay. All right. So we've already found two of them. We're halfway done, y'all. We found the value of D. We found the value of dx. I'm going to come back up here. So I'm going to highlight which ones we found. Okay. We got two more to do. We're halfway done. Okay. I know it takes a long time, but we're halfway done. Okay. So look, let's do the dy, and I'm going to show you how I'm going to do the dy right here. So we're going to say dy, and it's going to look like this. Okay. Remember what I'm going to do? I'm going to come back over here, and I'm going to say, look, I'm not going to use those numbers in the middle. I'm going to replace those numbers with these right here. So I'm going to just start copying my numbers. As I go down, I have 2, 3, 1. And then the second set of numbers is going to be -2, -3, and 17. And then my last numbers are the numbers that I have right here, which are 4, -1, and +2. 4, -1, and +2. 4, -1, and +2. And again, y'all, just like we did before, I'm going to go 2, 3, and 1, and -2, -3, and 17. Okay? I don't know, it takes a long time. I don't even like doing these problems. And I teach math, right? Okay, so let's go through one piece at a time. So we're going to go 2 times -3 times 2 plus, let's see, -2 times -1 times 1 plus 4 times 3 times 17, okay? And then remember, minus, I'm going to use my red like I've been doing before. I'm going to go along these diagonals. 1 times -3 times 4 plus 17 times -1 times 2 plus 2 times 3 times -2. Okay. All right. So now that we have this part, let's see if we can find our answer. Let's see. When I take these numbers here, 2 times -3 times 2 is going to be a -12. Plus, let's see, -2 times -1 times 1 is a +2. 4 times 3 times 17, I don't know. 204. Minus, let's see, 1 times -3 times 4 is a -12. 17 times -1 times 2 is a -34. And 2 times 3 times -2 is also a -12. Okay. So now I'm just going to use my calculator to do this first part. So -12 plus 2 plus 204. Oops. -12 plus 2 plus 204 is 194. This is 194 minus, let's see, these are all negative. Oops. Okay, so let me clear that out. We have a -12 minus 34 minus 12 again. That's a -58. Okay, so remember, minus and minus is going to give me a positive. So 194 plus 58 is 252. Okay, so I got my value for dy. dy is 252. Okay. All right, so we got one last one to do. So let's do the very last one. So the very last one, y'all, is going to be the dz, and I'm going to show you again how I'm going to write this out. Get my pen working. Here we go. Okay. So here's my original problem. And again, just to give you a heads up on what I'm going to do, I'm going to replace these three numbers here with those three numbers there. So my first three numbers going down are still going to be 2, 3, and 1. So let me write that here. Oops. 2, 3, and 1. And then my second numbers are still going to be the numbers that I have in the middle, which are -1, excuse me, -1, 2, and 4. let me write that here. Negative 1, 2, and 4. And now my last numbers are going to be these right here. Negative 2, negative 3, and a positive 17. Negative 2, negative 3, and a positive 17, okay? And then just like we did before, we're going to copy the first two columns down. Okay. All right. Let's do it to it, because this is the last one we got to do. Okay. So we're going to take, so this is again DZ. This is going to be 2 times 2 times 17 plus negative 1 times negative 3 times 1 plus negative 2 times 3 times 4. Okay. All right, then we're going to go minus brackets, and I'm going to use my red like I've been doing so far. So 1 times 2 times negative 2 plus, right here, 4 times negative 3 times 2 plus, let's do this part right here, 17 and 3 and negative 1. Okay. All right. So now let's go ahead and get these last numbers crunched. So we got 2 times 2 times 2 times 2 times 17 is 68. Okay. So my first number here is 68. Negative 1 times negative 3 times 1 is a positive 3. Negative 2 times 3 times positive 4 is a negative 24. Minus, let's see, that's a negative 4 right there. Let's see, 4 times 3 is 12, times 2 is 24. That's a minus 24 right here. Okay. And then 7 times 3 times negative 1 should be a negative 51. 17 times 3 times negative 1, right? Am I okay? Because I'm doing this column right here, that diagonal, right? So let's see. Let's hope we're doing this right, because we've done all this work. We don't want to make mistakes. Minus 24. Okay, so this part here is 47 minus, let's see, all these here are negative. So we can say negative 4 minus 24 minus 51. That's a negative 79. And then remember, minus and minus become plus. So 47 plus 79 is 126. Okay. All right, so let's see. DZ is 126. Okay, so now let me show you what I'm going to do. I know I zoomed out a whole lot. I'm going to write, so we found every one of those there. Okay, so I'm going to write the values that we got earlier. So D was 63. Okay, so let me zoom in here. I'm just going to write my numbers real quick. So D was 63. DX was negative 189. DY was 252. And finally, DZ, oops, come on, pen. Here we go. Finally, DZ was 126. Okay, so now that I have those four values, let me show you how we're going to find the values of X. Value of X is going to be dx divided by d. So remember who we got for dx. We got a negative 189, and we got a 63 for d. So look, I'm going to do this. I'm going to take my calculator, 189 negative divided by 63 positive. So x equals negative 3. Okay. Then we're going to find our value for y. So our value for y is going to be dy divided by d. Okay. So dy was a 252 divided by 63. So 252 divided by 63 was a positive 4. There's my value of y. And then finally, the value of z, y'all, is going to be dz divided by d. So in this case, it is 126 divided by 63, and that should be equal to 2. Okay. And so what's our answer here? Negative 3, 4, and 2. Okay, and we found our solution using Cramer's rule. Lengthy process, y'all. I think in the homework for 5.3, I gave you one. In your class assignment 2, I just had you find half of this. Your class assignment 2 was just, can you just do this part right here? I don't have you go through the entire thing. I just want you to find the value of x using Cramer's rule, okay? So it's much less work that you have to do for your class assignment. You're not finding all 3 parts. You're just finding the determinant dx. You're just finding the determinant d, so that you can then find the value of x, okay? So again, just a heads up, that's what your class assignment 2 is, right? Let me go ahead and stop recording since we are done with this part here.